Hello everyone, good morning. My name is Damanpreet Kaur and today I am presenting my dissertation titled Fake News Detection Using Machine Learning and Python. This study uses the ICOT fake news dataset and compares four supervised models. I will explain the problem, methods, finding, evaluation, limitations and conclusions of this research project. So this slide shows the problem, aim, and questions. This research focuses on online misinformation and its information effects on trust, journalize, and decision making. Machine learning can support early detection, but high accuracy may result for leakage or publisher bias. Therefore, this study developed a reproducible classification pipeline and critically examined model performance, errors, reliability, and generalizability across context. So this is methodology pipeline. The study used a controlled quantitative experimental design based on public secondaries data. The ISOT dataset included fake CSV and true CSV. Real articles were labeled 0, while fake articles were labeled 1. Titles and bodies were combined duplicates, removed, and clean text transformed into TF, IDF, unigram, and bigram features during modeling. Dataset audit and supplement. The original dataset contained 44,898 articles. The audit found 209 duplicate rows and 5,079 repeated combined articles. After cleaning, 39,103 unique records remained, included 21,196 real and 17,907 fake articles. Furthermore, a stratified 80 divided by 20 split produced 31,282 training records and 7,821 test records to support a fair and consistent model evaluation. So this slide shows the exploratory data and analysis. Exploratory analysis showed the dataset was reasonably balanced with around 54% real and 46% fake articles. Subject categories were strongly linked to labels, and fake news data were less consistent. Fake articles were slightly longer, but overlapping length distributions showed that articles' size alone could not explain performance. So, this is a lexical EDA. Lexicon analysis identified clear dataset specific patterns. Real articles often included formal reporting words, while faking articles used political names, conversational language, captions, and social media expressions. Readers' term and data lines were removed, but publisher style may remain. Therefore, the model classified learned pattern rather than independently verifying factual truth or meaning. Model design and evaluation. For machine learning, models were compared logistic regressions, sport vector machine, multinomial neighbors, and random forest. Each model used the same clean text, TF, IDF settings, and data split. Performance was measured using accuracy, balanced accuracy, precision recall, F1 store, and ROC AUC, confusion matrix, and training time for comparison across all models. So this slide shows the main result. A sport vector machine achieved the strongest result with a 99.18% accuracy and 99.27% precision, 98.94% recall, 99.11% F1 score, and 0.9996 ROC AUC. Logistics regression ranked second. Random Forest had lower recall, while Navy Wares was fastest but weakest. SVM provided the best overall performance and efficiency balance during testing. SVM error profile. So the selected SVM correctly classified 4,213 real and 3,544 fake articles. It produced 26 false positives and 38 false negatives and making 64 errors from 7,821 test records. These errors remain important, so the system should support screening only. Final decision should carefully involve human review, source checking, and independent verification. Discussion and limitations. The ROC and precision recalls curves confirmed excellent in domain performance, especially for SVM and logistic regression. However, reliability is limited by publisher style and dataset characterized. Although obvious leakage was reduced, some sources related patterns may remain performance on different publishers, countries, languages, topics, or time periods is still uh, uncertain in practice. So, this is our conclusion and future work. In conclusion, the dissertation created a reproducible Google Colab pipeline, cleaned the ISOT dataset training for models, and compared their performance. Support vector machine achieved the highest F1 score and fused errors. However, high accuracy is not factual verifications. Future research should use external dataset, time-based validation, transformers, and human review. References. These slides present the academics references used throughout the dissertation. The dissertation code was developed in Google Colab and contains a complete processing, training, testing, and evaluation pipeline. Thank you, everyone. So this is my code. Thank you.